Hi, welcome to week 2 of Understanding Quantum Computers. We're going to take a look at some of the questions you've asked in the comments over the last week or so. First, I want to say we're really happy with the level of activity and the feedback that you all are giving us on the content of the course. So I hope that having this kind of video will help your understanding and that we can use this as a continuing part of the dialogue. So first up, let's take one of the questions on the representation. So we were asked how this, our 003 qubit ket, equals this. 1, 0, 1, 2, 3, 4, 5, 6, 7.
Yes.
All right.
Yeah, I think so.
You think so?
Yeah.
So we were asked how this 000 state becomes this vector with a 1 in this first element. So this would be for a 3 qubit system. So we got 3 qubits here. 3 qubits. And because there are 3 qubits, we have 2 to the 3 equals how many?
8.
8. Okay.
Yeah.
8 states. There are 8 possible states in our system. 1, 2, 3, 4, 5, 6, 7, 8. Now, mathematically, each of these represents a separate dimension. So we can have sort of this value in 8 separate dimensions. And the value in each one of these is our amplitude in one of those 8 dimensions. But for each one of these, we can pick a label. So as it happens, we have labeled this the 000 state. Now, it could be anything, actually. We could call this, I don't know, our human with no hair state. And we could call this one our human with a lot of hair state. We could call this one our cat state.
Mm-hmm.
We could call this one our, I don't know, umbrella state. Doesn't matter. You can put anything you want inside those labels. You're just labeling each of the elements in this. It's the same thing with classical computers. You have your 0 and 1 states. They correspond to 2 different physical states. They correspond to maybe a low voltage and a high voltage, or the polarization of a magnet being this way, or the polarization of a magnet being this way, but it could be anything. It could be the position of a rock or anything that corresponds to your computational basis states. So you have physical phenomena and your logical state representation. So this is just one of the states, and we call it our 000 state. That's really convenient for us because we have set up the physical system so that we have 3 separate physical qubits. Maybe we can draw those as circles just for fun, right? So each one of these has the possibility of being up or down independently. So that's where our 2 states for each one of these comes from. And because this can be up, 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 or up, down, up, or any of the 8 possible combinations, that's why there are 8 elements in these vectors, and we call this our 8 basis states. So this is one of our basis states, and we set up our computation so that we treat this as if it's 3 zeros in our state as we go. I hope that helps with that particular question. If that's not good enough, you'll come back and ask us some more, and we'll tell you some more, or do our best to explain it.